Hey guys, welcome back to another Mathin' with Coach Lynn. Today we're going to cover Lesson 4.7, Absolute Value and Distance. This begins on page 253 in our Tennesee Reveal Math book. The I can statement states, I can use coordinates and absolute value to find the distance between points with the same x or the same y coordinates. Now we're going to start in our Learn section and we're going to find horizontal distance. You can find the horizontal distance between 2 points with the same y coordinate on the coordinate plane by using coordinates and absolute value. When 2 points are in the same quadrant, they have the same y coordinate. Subtract the absolute values of the x coordinates to find the distance between the 2 points. So we have a point -5, -4, and point -1, -4. Since they have the same y, we're going to find the distance using their x value. And since they're both in quadrant 3, we are going to subtract the absolute values of the x. So absolute value of -1 is 1. The absolute value of -5 is 5. So we're going to subtract the absolute values. 5 minus 1 is 4. So the distance between the 2 points that we have graphed is 4 units. Continuing on page 254, when 2 points are in different quadrants and they have the same y coordinate, add the absolute values of the x coordinates to find the distance between the 2 points. So we have -4, 2, and 1, 2. They have the same y, but different x's. And we see that they're in different quadrants. So we're going to take the absolute value of their x value and add them together to find the distance. So the absolute value of -4 is 4, and the absolute value of 1 is 1. So 4 plus 1 is 5. So these 2 points are 5 units apart from each other. Now let's look at example 1. Find the horizontal distance between the 2 points. So the first thing we need to do is identify the ordered pair for each point. So we have u, which is located at 1/2, -1 and 1/2. So go ahead and write that ordered pair. Remember, our x is our horizontal line and our y is our vertical. X always comes first. And then v is at 2, -1.5. We'll go ahead and write that in, 2, -1.5. So since the y coordinates are the same, we're going to find the absolute value of the x coordinate. So in u, the absolute value of 1/2 is going to be 1/2. And in v, the absolute value of 2 will be 2. And like we said earlier, if they are in the same quadrant, we subtract the absolute values. So 2 minus 1/2 would give us 1.5. So u and v are 1.5 units apart. Now let's look at our check problem at the bottom of the page. Find the horizontal distance between the 2 points. So we have P and Q. Well, P is located at -5, -2. And Q is located at -2, -2. Since they have the same y, we will compare the x's. Take the absolute value of each x, absolute value of 5, or -5 is 5, and the absolute value of -2 is 2. Since they are in the same quadrant, we'll do 5 minus 2, which gives us 3. So the 2 points, P and Q, are 3 units apart. Question 1 wants us to find the horizontal distance of point A and point B, and they are in the same quadrant. Point A is at the spot between 0 and 0.5, so we know that is 0.25 or 1/4. And for the y, it is at 1. B is located between 0.5 and 1. So we know that'll be 0.75, and it is also at 1 for the y. Since the y's are the same, we'll take the absolute value of the x's. Absolute value of 0.25 is 0.25. The absolute value of 0.75 is 0.75. Now, we have to subtract them since they are in the same quadrant. So 0.75 minus 0.25, we're going to get 0.50. So our points A and B are 0.5 units apart, or half a unit apart. Now let's look at example 2. We're going to find the horizontal distance between 2 points, and they're going to be in different quadrants. So we have point E, which is at, we got a -1/4, which is 0.25, -1/2, which is 0.5, and then we're going to have -0.75, or -3/4 for our x. And then for our y, we're one block down. We know each block represented 0.25, so we're at -0.25 for the y. F is 1 over on the x-axis, so that's going to be a positive 0.25. And it's 1 down on the y, so it's -0.25 for its coordinates. Since the y's are the same, we are going to take the absolute values of the x's. So the absolute value of -0.75 is going to just be positive 0.75, and the absolute value of 0.25 is going to be 0.25. Since they are in different quadrants, we will add them together. So if I add those two together, 5 plus 5 is 10. Put my 0, carry my 1. 7 plus 1 is 8. Plus 2 is 10. 10 right there. Bring down my decimal, 1.00. So the distance between E and F is 1 unit. Now the check problem at the bottom of the page, find the horizontal distance between the 2 points K and L. We see K is at -2, +1. L is at +1, +1. Now since our y's are the same, we're going to take the absolute value of the x's. So the absolute value of -2, which is 2, and the absolute value of 1, which is 1. Since they are in the different quadrants, we will add them. 2 plus 1 is 3. So K and L are 3 units apart. We can see this, 1, 2, 3, confirms that. Number 3, we're going to find the horizontal distance between 2 points that are in different quadrants. A is at -2, and it looks like each box represents a half, so -2 is the x, and +1/2 is the y. And B is at +1, +1/2. Now since the y's are the same, we're going to take the absolute value of the x's. So the absolute value of -2 is 2. The absolute value of 1 is 1. So we're going to add them together since they are in different quadrants. So 2 plus 1. 2 plus 1 is 3. So our points A and B are 3 units apart. Now let's look at finding the vertical distance on page 256. Finding the vertical distance is very similar to finding the horizontal distance, but the x coordinates will be the same, so we'll be comparing the y coordinate. So we have a point 3, -1, and 3, -5 on our graph. So since The x's are the same. We're going to look at the y's. Absolute value of -1 is 1. The absolute value of -5 is 5. And since they're in the same quadrant, we are going to subtract 5 minus 1. That'll give us 4. So the 2 points are 4 units apart. If they are in the same or different quadrants, we're going to add. So we have 0.21 and 2, -4. So we're going to look at the y's. Since the x's are the same, absolute value of -4 is 4. Absolute value of 1 is 1. Like I said, since they're in different quadrants, 4 plus 1 is 5. So they are 5 units apart. Example 3 on page 257, we're going to find the vertical distance in the same quadrant. We have point D, which is -1, -0.5, and C, -1, -2. So the x coordinates are negative, the y coordinates are negative. So we're going to identify which quadrant is in. Well, if we have our coordinate plane, we know that quadrant 1 is to the right of our origin, which is 0, 0. So it's positive, and it's above 0, so it's positive. So both points are positive in quadrant 1. Quadrant 2 is to the left of 0 on the x, so it's negative. And it's above 0 on the y, so it's positive, so it's a negative positive. Quadrant 3 is to the left on the x, so it's negative, and it's below 0, so it's also negative in the y, so negative, negative. And then quadrant 4 is to the right of 0 on the x, so we know it's positive, and it's below 0 on the y, which is negative. So quadrant 1 is positive, positive. Quadrant 2 is negative, positive. Quadrant 3 is negative, negative. And quadrant 4 is positive, negative. So since both of our points are negative, negative, we know they belong in quadrant 3. So the x coordinates are the same, so we're going to look at the y's. We'll take the absolute value of the y coordinate. Absolute value of -2 is 2. Absolute value of -0.5 is 1/2. So since they are in the same quadrant, we subtract 2 minus 1/2 is 1.5. So points C and D are 1.5 units apart. Our check problem, we're going to find the vertical distance between A and B. A is at -1 1/3, -2 1/3. B is at -1 1/3, -1 1/3. So the x's are the same. So we know we're going to compare the y. They both have negative x and y values, so we know they are in quadrant 3. So they're in the same quadrant. So we know once we get our absolute value of our y's, we are going to subtract since they're in the same quadrant. So we have the absolute value of -2/3, which is going to be 2/3, and the absolute value of -1 1/3, which is positive 1 1/3. Like we said, since they are in the same quadrant, we will subtract. So we have 1 1/3 minus 2/3. So if I take 1/3 from that, that's going to make that 1. So I'm going to have a whole, and then I'm going to take another third to make my 2/3. So it's going to be 2/3. I can also make this an improper fraction to help me. 3 times 1 is 3, plus 1 is 4. So I have 4/3 minus 2/3. In order to add or subtract fractions, they must have the same denominator, which they do. 4 minus 2 is 2. And we keep our denominator, which is 3. So we see that points A and B are both 2/3 units apart. Number 5, the x-coordinate is -2, 3, and the y-coordinate is -2, 1 1/4. Since our x's are the same, we're going to compare our y's. So we have the absolute value of 3, which is 3, and the absolute value of 1 1/4, which is 1 1/4. So we're going to have to identify whether they're in the same quadrant or different quadrants. So if I have my coordinate plane, I know quadrant 1 is here, 2 is right there, 3 is down here, and 4 is in the bottom right. Quadrant 1 is to the right and to above our origin. So we know quadrant 1 consists of positive points. Quadrant 2 is to the left of 0 and above 0. So we know it is a negative positive point. Quadrant 3 is to the left and below 0. So it is a negative point. And quadrant 4 is to the right and below 0. So it is a positive negative point. So we see that our points are negative, positive, which means they're both in the same quadrant, and we know they're both in quadrant 2. So since they're in the same quadrant, we're going to have to subtract our y's. So we have 3 minus 1 1/4. I'm going to convert 1 1/4 to a decimal. I know 1/4 is the same as 0.25. So I have 3 minus 1.25. I'm going to have to borrow from my 3, borrow from the 10. So I have 10 minus 5 is 5. 9 minus 2 is 7. Bring my decimal down. 2 minus 1 is 1. So the distance between x and y is 1.75 units. Now example 4 on page 258, we're going to find the vertical distance in different quadrants. So the vertical distance between point S, 1 and 0.5, and T, 1, negative 0.5. So the x coordinates are the same signs. The y coordinates have different signs. Since they don't have the same sign in both the x and y, we know they are different quadrants. S is positive, so we know it's in quadrant 1. T is positive, negative, so we know it's in quadrant 4. So since they're in different quadrants, we know we're going to add the coordinate that is different. They have the same x, but they have different y coordinates, so we're going to end up adding the y coordinates. First, we're going to find the absolute values of the y's. Y is 0.5, so the absolute value of that is 0.5. T's y is negative 0.5, and the absolute value of that is 0.5. So since they are in different quadrants, we add 0.5 plus 0.5 equals 1. So points S and T are 1 units apart. Now our check, we have point E, 0.5, 1.5, and F, 0.5, negative 2. Well, we know E is positive, so it's in quadrant 1. F is positive, negative, so it's in quadrant 4. So they are in different quadrants, so we're going to add. Now we're going to look at our y's and get the absolute value. So the absolute value of 1.5 equals 1.5, and the absolute value of negative 2 equals 2. So we're going to do 1.5 plus 2. 5 plus 0 is 5. Bring our decimal down. 2 plus 1 is 3. So points E and F are 3.5 units apart. Question 7, finding the vertical distance in different quadrants with A and B. A, negative 1, 1.5. B, negative 1, negative 1.5. Since A is negative positive, we know it's in quadrant 2. B is negative negative, which we know is quadrant 3. So we see that they're in different quadrants, so we're going to add. So we have the same x. We're going to look at the y since they're different. The absolute value of 1.5 is 1.5. And the absolute value of negative 1.5 is 1.5. So 1.5 plus 1.5, since they are in different quadrants. 5 plus 5 is 10. Bring my 0, carry my 1, drop down my decimal. 1 plus 1 plus 1 is 3. So we have 3.0. So point A and B are 3 units apart. Now let's take what we've learned about finding the distance between coordinates and use it in our apply problem to see a real-world scenario. Fritz and Manolo like to skateboard together at a nearby park. They want to determine who has to walk the further distance to get to the park. So they graph their locations on a coordinate plane. With the city's main square at the origin, the coordinates for each location are shown on the table. Each unit represents a city block. Who has to walk the farther distance to get to the park? So what we're going to do is we're going to have to find the distance from the park to each person's house. So the park is at 3, 2. And let's look at Fritz's house, which is at -2.5, 2. Well, since they have the same y's, we're going to compare the x's. Okay, so the absolute value of -2.5 is going to be 2.5. And the absolute value of 3 is 3. Well, Fritz's house is at -positive, so we know it's in quadrant 2. The park is positive, so it's in quadrant 1. So they're in different quadrants, so we're going to add our absolute values. So 2.5 plus 3 is 5.5. So the park to Fritz's is 5.5 blocks. Now, park at 3, 2. Manolo's house at 3, -3 3/4. So they have the same x, so we're going to compare the y. Get the absolute value of -3 3/4, which is going to be +3 3/4. And the absolute value of 2, which is 2. Well, Manolo's house is at +negative, so we know it's in quadrant 4. So it's in a different quadrant than the park as well. So we're going to add our absolute values, 3 3/4 and 2. So that will give us 5 3/4 from the park to Manolo's. When we compare these, 5.5, 5 3/4, we see that it is a farther distance to Manolo's house from the park than it is to Fritz's. Okay, guys, I hope what we've done in lesson 4.7 is useful for you to be able to identify the distance between points, whether it be the distance on the horizontal axis or vertical axis. Being able to compare the x's and the y's. Take what we've learned, move forward, and have a great day.